Good afternoon, everybody, or morning if you're watching this later. I'm going to go over a little bit of the Mobius circuit with related rates and first and second derivative. Just a couple of the problems. Just want to kind of go through and make sure that you're doing it correctly. So when you look at this, we're going to go to this scene right here. This problem right here is a good one. It says find the critical numbers, both critical numbers. Identify the leftmost critical number. So the leftmost critical number is going to be the leftmost x value. So a critical number occurs at the derivative when the derivative is equal to 0. So I'm going to find the derivative of this function, which is this. I'm going to factor out the 3. I'm going to factor it. I'm going to solve for x. And my leftmost value is going to be negative 5. All right, moving on to the bottom right where it says a particle is moving along the given curve with dy dt is equal to negative 6 and x squared plus y squared is equal to 25. Find dx dt when x is 3 and y is 4. So what this is a unit circle. Well, it's a circle with a radius of 5 if you notice. So if I take the derivative, I get 2x. Now in this case, I need a dx dt because I don't have a t in there, so I gotta take the derivative of x with respect to t. I got plus 2y dy dt equal to 0. I got values for x, which is 3. I got values for y, which is 4. I got a value for dy dt, which is negative 6. And if I simplify all that and solve for dx dt, I get the value of 8. So derivative, plug in, solve. All right, we're going to move to the second page now, and we're going to look at this one with the critical numbers between 0 and pi. The leftmost critical number of this function, so I need the derivative. So the derivative is going to be a 3. 3 stays out front. The derivative of cosine is negative sign, so this negative goes with that negative sign, times the inside, or keep the inside, times the derivative of the inside, plus the derivative of 2x, which is 2. I need to find critical numbers, so I need to set that equal to 0. And when I set that equal to 0, and I solve for at least this part, I get sine of 4/3 x equal to 1/2. Now, how to solve that type of equation? If I look at sine of u, if I replace u to the 4/3 x, I can get where sine of u is equal to 1/2. Sine of u equals 1/2 at pi over 6. So, because u I replaced with 4/3 x, I'm going to take that 4/3 x and set it equal to my answer. So I get 4/3 x equal to this, and then I'm going to solve for x by multiplying by 3/4. So 3/4 times pi over 6 gives me pi over 8. Alright, and then the last one that we'll go over is the one right above it. It says f of x is equal to 3x to the 4th minus 8x cubed minus 96x squared plus 384x minus 110. On the interval from negative 5 to 4, identify the value where x is the absolute occurs. So, derivative, I factored by grouping. I get 12x squared plus 192. So you got to be able to factor that. And x minus 2 is the common. So it gives me x equals 2 and x equals plus or minus 4. So now what I have to do is do a table. I have to take the endpoints because the max or the min can occur at an endpoint. And I take the ones that are in the 4 is already in it, and negative 4 is, and I'll check 2. And when I plug this into the original equation, I get these values. I use my calculator. That way it was easier to find out. Negative 1,555, negative 1,902, 258, and 146. So the max occurs at 2. Okay. Now, that one ties into the one that is 1, 2, 3 down from that. Identify where, because this is the same equation, that's the same interval, where does the minimum occur? So the minimum occurs at negative 4 and negative 1902. So that answer is negative 4. I thought it was 5, but it is negative 4. All right. Also on there is the sphere and the conical sand, and make sure there's a couple things that go along with it. If you're not following along, shoot me an email and I will send you the volume and the conical one, and we can do a live chat, or I can tape that if you need to, if a lot of people are asking for it. All right, so that's the Mobius circuit. The circuit has 2 circuits in it, and I kind of color coded them. The ones in blue are the ones with the spherical. The ones in pink are the ones that are the separate circuit, and then the ones in brown colored are the ones that go with the cone. Okay? Hope you enjoyed.